Welcome to further mathematics class. In this class, I'll be taking you through trigonometric ratios, lesson outline, quadrants and angles, basic trigonometric ratio, ratio of special angles, trigonometric function, and trigonometric equations. Quadrants and angles. The x and y axis partition the planes into 4 parts. Each part is called a quadrant. If we move in anti-clockwise direction, the angle at the first quadrant is 90 degrees, which is also pi over 2 in radian. The angle at the second quadrant is 180 degrees, which is pi in radian. The angle at the third quadrant is 270 degrees, which is 3 pi over 2 in radian, while the angle at the fourth quadrant is 360 degrees or 2 pi. The angle between each of the quadrants is 90 degrees. And if you add the sum of angles at each of the quadrants together, it gives 360 degrees. Basic trigonometric ratio. Sine of angle is equal to opposite over hypotenuse. Cos of angle is equal to adjacent over hypotenuse. While tangent of angle is equal to opposite over adjacent, from the word SOHCAHTOA. The side directly facing the rectangle is called the hypotenuse. The side facing the angle indicated is called opposite, while the side facing the angle that is not indicated is called adjacent. Also note that the longest side of a right-angled triangle is hypotenuse. Reciprocal of basic ratios. Secant of angle is equal to hypotenuse over adjacent. Cosecant of angle is equal to the hypotenuse over opposite. And cotangent of angle is equal to adjacent over opposite. The reciprocal of basic ratio is also known as the inverse of the basic ratio, because secant of angle is equal to 1 over cosine of angle. Cosecant of angle is equal to 1 over sine of angle, while cotangent of angle is equal to 1 over tangent of angle. Ratio of special angles. The ratio of special angles are obtained from an isosceles triangle and equilateral triangle. Consider triangle ABC. Triangle ABC is an equilateral triangle. Side AB is equal to side AC is equal to side BC. All the three angles are the same, and they are 60, 60, 60 degrees respectively. The triangle ABC is divided by line AD, which means that angle BAD is equal to 30 degrees. Also note that line BD is equal to line DC, and they both have the value 1. Now, considering triangle ABD, triangle AB has the value 2, triangle BD has the value 1, and triangle AD has the value of root 3 from Pythagoras theorem. Now let's consider another special angle, which is angle 45 degrees. Now let's consider triangle PQR. Triangle PQR is an isosceles triangle. Why? Because two sides are equal. Now PR is equal to RQ, and they both have the value of 1. Now, from Pythagoras' theorem, the longest side of the triangle is the hypotenuse, which is PQ. Also note that PQ is gotten by taking the square root of the square of the adjacent and the opposite. The adjacent in this case is PR, while the opposite in this case is RQ. Now, taking the square of PR and RQ, we have 1 square plus 1 square, which is equal to 2. Square root of 2 is equal to 2, and that is the hypotenuse. Ratio of special angle. Considering the two triangles that we observed earlier, the first special angle is 30 degrees, the second is 45 degrees, and the third is 60 degrees. Now, to get sine 30 degrees is opposite over hypotenuse. And from the triangle, the opposite is 1 and the hypotenuse is 2. That's the reason why we have 1 over 2. And for sine 45 degrees, considering the second triangle, the opposite there is 1 and the hypotenuse is root 2. And that's the reason why sine 45 degrees is equal to 1 over root 2. Also, sine 60 degrees is opposite over hypotenuse. The opposite in this case is root 3, while the hypotenuse is 2. And sine 60 degrees is equal to root 3 over 2. The same applies to cos and tan. Trigonometric function. 3 basic trigonometric functions are sine, cosine, and tangent. Is represented by y is equal to sine x, y is equal to cosine x, and y is equal to tangent x. Graphs of trigonometric functions. Sine graph. Y is equal to sine x. The curve passes through the origin when x is equal to 0 and y is equal to 0. The maximum value is 1 and the minimum value of y is minus 1. Cos graph. Y is equal to cos x. The curve does not pass through the origin but rather in the positive side of y, which is plus 1. And for tan graph, the curve is discontinuous and it does not pass through 90 degrees and 270 degrees. Sine graph. To expatiate more on the sine graph, when the value of x is equal to 0, sine 0 is equal to 0 because it passes through the origin and there is no amplitude. Also note that x has attained maximum value at 90 degrees, which gives 1. Cos graph. The curve does not pass through the origin, but rather passes through the positive and negative side of y. And at that point, the value of x is equal to 0, and that is maximum on the y-axis. So, cos 0 is equal to 1. Also, when x is equal to 90 degrees, the curve is already at the 0 level of y. Tan graph. The curve is discontinuous and it does not touch 90 degrees or any values of x. Trigonometric equation. A trigonometric equation is an equation containing trigonometric ratios. Example, find the value of phi between 0 degrees and 360 degrees, which satisfy the equation 4 cos square phi minus 3 is equal to 0. Solution. 4 cos square phi minus 3 is equal to 0. By taking negative 3 to the other side, it becomes 3. Therefore, 4 cos square phi is equal to 3. Make cos square phi the subject. Cos square phi is equal to 3 divided by 4. Therefore, cos phi is equal to square root of 3 over 4. And that gives us plus or minus square root of 3 over 2 or root 3 over 2. These are two values, both positive and negative. Then if phi is equal to plus root 3 over 2, then phi is equal to 30 degrees and 30 degrees. But if phi is equal to minus root 3 over 2, then phi is equal to 150 degrees and 210 degrees respectively. Hence, the value of phi between 0 degrees and 360 degrees satisfying the equation are 30 degrees, 150 degrees, 210 degrees, and 330 degrees. Thank you for listening.